So this is just a quick introduction to the start of this one, which is all about 2-litre Vauxhall HotRod engine. I've already filmed the engine, I've already filmed the ending, but I've realised I haven't done the start, so this is the start. This is virtually all Vauxhall red top hot rod. Hope you enjoy. So today I'm assembling the National HotRod 2-litre Vauxhall. I've knocked the core plugs into it already. I've fitted the water pump. I've taken the back shield off the water pump because I run a different style of belt guard, which I'll show later on in the build. So I have to cut the back shield off, so that's gone. Next thing I've got to do is gap the rings, but first of all I'm going to check the weight of the pistons and just record the weight of the pistons and the conrods, and then gap the rings and then fit them. So first thing I'll go and do is weigh them. So this is me just checking the weight of the pistons on the National HotRod engine. So I just use some paint scales because they're really accurate. So on here I've put a second ring, top ring and one circlip, and then each piston has already got the oil control ring on because I've checked them. There's one clip already installed and the gudgeon pins installed, so it's a full kit that I'm testing. So basically I weigh one and then see what it weighs and then reset it to 0. So there I've got a 0 setting, and then it will tell me if the other pistons are heavy or light. So number 2. Number 3. Number 4. They're all within 0.3 of a gram of each other, so I'm going to leave them at that. Most people balance with a tolerance of a couple of grams, but I like to get it less than a gram, so at 0.3 that'll do. So now I'm checking the conrods, and I do that by setting the scales up with this. This checks the conrod end to end, so it allows me to check the small end and the big end. So set the machine up. And I'll do all the small ends first. But it's really important to make sure they're sitting on the machine at the same position. And then the big scale is taking the weight of the conrod in total. So this one's showing that it's a slight bit heavy on the big end. So I'm just going to have to adjust this one conrod here on the big end. And then just to double check things, I put them on the paint scales again to check the whole weight. And I'm hoping that the one which has got the slightly heavy big end is slightly heavy in total weight as well. If not, I'm going to have to machine all the rods to get them spot on. So I'll put one rod on first, set my 0, Yeah, and just as the small scale's red on the big end, showing that it's 1/2 gram heavy, that one conrod. So I'll quickly just adjust that in across the top by 1/2 gram, and then recheck it. So the next thing that I'm doing on this National HotRod engine is working out the compression ratio. This piston here, or all the pistons, they're called intruder pistons. So the top of the piston comes above the top of the block. So to work out the compression, I have to first find TDC and then drop the piston in the hole by a certain amount to work out what cc's are in that amount, then work out how many cc's are in what's left, and then take one away from the other, and it gives me the cc's in the bottom end. So what I've done with this so far is I've worked out how much gap I've got from the top of the piston ring to the top of the piston. So I've wrote that calculation down. So now I've dropped the piston down the hole by 6 mil. So the next thing to do is work out how many cc's are in 6 mil of this bore. So to do that, it's quite a simple calculation, but I do need a calculator. Right, so 6 mil down the bore at the bore size equals 36.08 cc's. Now the other thing that I can work out from here is the actual finished cc of the engine. So to do that, it's the same calculation, but instead of it being the 6 mil which I've dropped the piston down the hole, it's now the stroke, which is 86 mil on this engine. So to do that, I just put the numbers in the calculator. So if I work it out on one cylinder, that gives me the swept volume of the cylinder, and then times it by 4 gives me the finished cc of the engine. So the finished cc of this engine is 2068, so it's just over a 2 litre now. The swept volume is 517.20. The swept volume is from bottom dead centre to top dead centre. So from that now, I'll need to seal this up good with grease, and then put a layer of grease around here, put my glass on top, and then fill what's left with fluid with one of the barrettes, and that'll tell me how many cc's are in this, and then I take the one figure away from the other, and that will tell me the cc's that's left in that. So I'll record doing that. So what I'm doing now is seeing how many cc's are in the block. To do this, I'm using my glass barrette, which I've zeroed. So very carefully, I just need to fill the cylinder up now. Takes a bit of getting used to. There we are. So that's finished up with being 31.1 in the cylinder. So I'll make a note of that. So that's that job done. And now I've got to check the cc's in the gasket. So on the hot rod engine, I've just got to quickly strip the pistons out of it, because the rules are you can only run a standard style gasket, which is this gasket here, and where the engine's been rebored, the bore of the engine is ever so slightly bigger than the gasket, and the piston comes out of the bore by 29 thou. So what I don't want to happen is the gasket getting hit by the piston, because it's very close. So I've taken the pistons back out. I'm going to take the rings off, and I'm just going to put a slight chamfer on the edge of here just to eliminate that problem. So I've got the piston mounted in the lathe, and the first thing that I need to do is make sure that it's running nice and true in the lathe. So to do that, I'm using my DTI, and I'm going to spin that to see how much movement's there. So now the piston's mounted in the lathe, I can spin this and see how much run out I've got, and then just adjust it slightly to suit. So with the piston now running through, I've set my stops on the lathe, and now I can just come in and chamfer the piston by the right amount. And there we are, that piston's got the right clearance now for the gasket. So 2 more to do. So that's the bottom end of the hot rod engine back together after just machining a slight chamfer on the pistons. So I'm going to have to recalculate the compression again just to make sure I'm accurate on that. It would only change it by a little bit, but it still would have changed it, so we ain't going to guess it, we're going to get it right. So I put the dry sump pan on, and how this works, as I explained briefly the other day, but I thought it's better to show you now the pan's on, is these 2 pipes here are called scavengers. So this external pump is driven by the crankshaft via a belt, and then the pump produces vacuum on the lower side. So as it's running, the oil that's being pumped into the engine is scavenged from the bottom, and then it's pushed out of this pipe then through the cooler or the filter system or whatever you've got back to the tank, and it works its way in the top of the oil tank. And some of them have a deaerator in it which makes the oil spin, and then this fitting at the bottom of the pump here, because that's still under vacuum, because this is the underside of the pump, the vacuum side of the pump, this then pulls oil from the bottom of the tank. So it brings the oil through the tank, through the bottom of the pump, and then once again it will come out of the top of the pump, because this is the pressure side of the pump, and then it will run through your filter before it goes directly into the front of the engine, straight into the oil gallery, and then it feeds feeds all the parts of the engine, goes up to the cylinder head and lubricates the camshaft and followers and all that lot. Then the oil works its way back down to the bottom of the sump down here, and then the process is repeated through the scavengers. So that's that all together. The belt's on. I've got the actual proper timing belt on the engine as well, and then if I just turn that on to TDC, which is just about there. So before, the piston come up and it wasn't a sharp edge, but it was an edge there, and then because this is an overboard engine and the only gasket we're allowed to run is a standard gasket. I was a little bit concerned because the piston comes out the hole slightly at the bore, that the sharp edge of the piston would, well, it would have hit the gasket. It would only have touched it. It might never have caused a problem, but I don't want to risk it. So I've stripped the engine again and put a chamfer on top of the piston, all the same in the lathe. Bit of an oversight by me, really. I should have dummy built it with just one piston in the bore, and then I would have spotted that straight away. But I didn't think it was going to cause a problem. It was the fact that we've got to use the standard gaskets. So now I've just got to quickly work the compression ratio out, and then finish the work and get the cylinder head back on the bottom end of the engine. So today I'm doing some work on the hot rod cylinder head. This had excessive guide wear in 3 of the guides, plus one of them, or one of them on one of the bad cylinders, and one of the other guides on the bad cylinders was excessively worn too. So I've replaced all 8 inlet guides, and also there was quite a bad scratch on the damaged cylinders exhaust guide. So I've replaced the 2 guides in the exhaust. The other 6 didn't need doing. They was in really good condition, so they was fine. I've honed them all to size. I don't know if I mentioned before, the original engine come in because the conrod had let go and just sliced through the block. I have got the original conrod out the engine, which I'll show you quick actually. Let me turn that down. So it's not that drop. It's not that drop. So on this Vauxhall, it come in for block replacement, but that is one of the conrods out of the engine. I think the piston, the gudgeon pin must have broken, then let go. I mean, the bolts were still together, but the crank was destroyed, the block was destroyed. It made a right mess, really. This is the rest of them, but what I did notice is there is quite a lot of small end wear there, so I don't know if that just if it was the gudgeon pin that let go or what. I haven't took it apart to see completely because I didn't really need to. I was replacing it all anyway. Nothing in this was going to get reused because it was all quite badly destroyed. So that's the drawer of broken engine parts. When engines come in and they're knackered, if there's a bad piston or something, I'll save it, because eventually in the new shop I'm going to build a table out of blown up engine bits. I think it looked quite cool. So that's another piston that let go. That's out of a 1600 Vauxhall. But there's conrods and broken cams and all sorts of bits and bobs in there. But that was the rod out the engine, so that's why it needed some major repairs to one of the cylinders, cylinder number 3. Anyway, I'm going to cut the rest of the seats and show the rest of the repairs on this cylinder head. So the last thing to do to this is just one more seat. I thought I'd actually record this one being done instead of time-lapsing it. So we fit the Myra seat cutter into the seat, press the button to centralise the pilot in the seat or in the guide, just like that, and then the computer tells us that it's centralised, so we lock the machine off, fit the Vera drive, and then just start to wind the machine down so it just starts cutting the seat, and listen for the seat cutter and watch the seat being formed. And there we are, there we have it. 16 freshly cut Vauxhall XE seats. So the next thing to do to this is to give it a reface. This is the cylinder that was damaged, so I just need to clean up some of the spots in there that might get hot. So I'll do that before I reface it, and then work the compression ratio out. Another thing that I'm doing today is I'm firing up my camshaft analyzer, because I'm on the hot rod. I'm reusing the customer's original cams, but I don't recognise what the profile is, so I'm going to run both bits of data for the inlet and exhaust. That will give me a baseline setting to where to set the cam timing to, and then we can just swing it around on the dyno to make sure it's fine. So I'll video that. So this is the camshaft testing equipment. This is a linear sensor and this is a rotary encoder. So you put some basic settings into the software. We can then turn the cam and it will tell us everything to do with the cam. So straight away, this is giving me the duration. It's also giving me the maximum lift, the base circle, opening and closing. So now I can set my tappets, get on with the cam timing, and know that it'll be pretty close, apart from tweaking it here and there with the vernier on the dyno to just get it absolutely bang on. This will get me close. And I've also now got a copy of the profile so I can compare it power wise to other engines that we build with different cams in it. So from this here I can graph the cam, and I can also test the velocity and the acceleration of it, so I know what it's going to be like on valve spring wear and stuff like that. So this is a glitch here, but to be honest, I didn't really need this bit so accurately. I was looking for more of this, so I'm not so fussed about that. I am going to redo it so I've got a good file. So the next one to do is the exhaust. So this is now the second cam that I'm testing for the hot rod. This is the exhaust cam. So once again, I've got all the data into the computer. So now I'm just gonna run it to see what we're at. So I've got to manually turn the camshaft in direction of rotation. And just as I thought, this is a bit milder than the inlet. So if I take this off here, there's the camshaft data for the exhaust. And then I can pinpoint what the maximum lift is with the cursor if I need to. And I can also move it to TDC to work out what lift at TDC that I've also got. So the information that this can give you is really good. So now I'm going to go ahead and set the tappets on this, save the data to go with the engine build sheet, and then set the cam timing ready for the dyno. So the hot rod cylinder head is all complete now. I've tidied up from the damage of the rod letting go. It's got a new set of valves in it. I've set the tappets. They was a fair bit out, but I carry quite a few shims in stock, so it's just a case of measuring them, getting the tappet clearance right, and then using the shim grinder to sort them out. So the next thing I'm doing is just working out the compression ratio. So for that I'm using this glass flat patch with 2 holes to let the air in and out, or the fluid in and the air out, and then a glass barrette. So I'll work that out and show the head on the engine. So we've got the cylinder head on the hot rod engine now. I've got all the gauges on it to do the cam timing. I'm setting it up lift at TDC because we're going to swing the cam timing around on the dyno. So all I need to do now is just nick these lock nuts off, get it, turn it around 2 complete revolutions again, just to see what my cam timing is set at, make a note of it, and then I know that I can adjust it when I get to the engine dyno. So what I'm looking for is TDC on this, and then these 2 gauges here will tell me lift at TDC. In fact, I'm going to go around again just to double check it. And there we go, that's absolutely bang on. So I'm going to make a note of what lift at TDC I've got on both gauges, and then like I say, I know that we can give it a little swing each way when we're on the engine dyno, just to try and get the power exactly where we want it. So all I've got left to do to this now is put the spark plugs in, inlet manifold and carburetors, rocker cover, flywheel and clutch. On the dyno that we run, it uses a inch 23 style Ford spline, so we just fit a Ford clutch onto the back of it and drive it off that. So we dyno it with the clutch fitted. And then I won't paint dot all the verniers until it comes off the dyno, just so I know that it's set to the optimum really. Because this is a hot rod, we want to get the cam timing absolutely bang on to get the absolute most out of the power and the torque. And that's it. I'll take the gauges off, make my notes, and I'll film the engine completely finished. So it's Thursday morning. I'm now just heading up to dyno the hot rod engine. My dyno, I lent out to a friend who uses his dyno all the time. He's really reliant on his dyno, and he had a problem with the computer, so I lent him my dyno computer. My dyno computer also had a slight problem, not the same problem as what his had, so he kindly fixed my dyno PC side of the computer, and I lent him the dyno computer, like the brain of the dyno. So his dyno's now fixed. The deal was he was going to dyno my engines for me while he had my dyno, so the hot rod's going up there for us to do together. So I've got the engine ready to load into the van. I've got the new computer and bits and bobs for me, because he's going to load the software onto the old computer which he's fixed, plus the new computer in case I have another problem. So having a little road trip to go and see my mate Paul. Filled up with diesel. I've got the V-Power fuel for the engine, so now we're on our way. So the engine's just starting to go onto the dyno now. It should take about half an hour, 40 minutes to get it on and plumbed in, and then we'll video it running. So it's the initial run of Joey's hot rod engine, and we're just bedding it in at the moment. Pulls on the controls. So we've dynoed the engine with the, is that the big exhaust or the small? With the small exhaust on. Got really good figures out of it so far, but what we're doing now, or what Paul's doing now, is just changing over from the small bore exhaust to the big bore exhaust. So we've got a comparison on exhaust sizes. So I'm back from the dyno. Well, it's the day after the dyno. So I just thought I'd run through the engine and everything with you. So that's the hot rod engine completely finished. Just got to put one of my grace plates in here and one of the belt guards in it. I'm just going to take a little bit of slack out of the belt where it's been run on the dyno. That's just give a little bit now. I'm going to drain the scavengers of oil, because these two scavenge pipes here stay with oil, but really happy with the dyno result, and so was Paul, whose dyno that I used. Another reason that I had to go and see Paul was to get my dyno computer back, and this. So this is my dyno computer that had a fault, so he was reloading the software on that for me and trying to sort the computer out. We don't think this computer's any good, so I bought a new computer which is there to take up to load the new software on, so I've got to sort that out. The spec of the engine is it's basically built to hot rod spec, so it's high compression, it's got special hot rod spec cams in it, new valve springs, new valves, because this is a new block, because the original block had cut through here, the conrod had let go and it had broke out here and broke out the other side. So new block, new crank, rods, pistons. I've repaired his original cylinder head, special hot rod spec cams, new valve springs, new valves, new followers, new tappet shims, which I've recorded all that being done. We've had to reject the carbs, and we had to play around with the cam timing. In fact, the exhaust cam didn't need moving at all. When we swung that each way, it lost power both ways, so that was set perfect. And we had to take a little bit of lift at TDC out of the inlet to get the best power, but that's all done now, that's all good. So just waiting for the customer to come and get it now. And to finish off, thanks for watching this vlog. This is virtually all about the hot rod engine. The next vlog will be a workshop update and a couple of other jobs. Anybody that's watching that hasn't subscribed, if you could subscribe, it would mean the world to me, to be honest. It helps me just keep focused on wanting to do it, seeing the subscribers go up. If you could also, if you're watching it, if you could also hit the thumbs up button if you like the video, that'd be awesome, and the little alert button as well. And I'll be starting the new vlog from tomorrow and adding some of the other footage of the unit. So thanks for watching, guys. Take care. Thank you. Bye.